Hi guys, can you hear me? Okay, very good, thank you. Okay, so hello everyone, welcome to the second Q&A live session, and also hi to everyone in the live chat who said hello. So today I would like to talk about answer your questions that you posted in the community session first, but second I would like to also pitch you an idea for future Q&A sessions, because if we do that now for a year, then I guess this might become a bit boring. So just let me make myself that was not good. The webcam, make it this a bit smaller here. Yeah, so you can actually see something. Okay, so then so I posted community post today, 7 hours ago, and I pitched my idea about possible live streams in the future. Of course, I'm happy to do Q&A sessions, but to mix things up, I've had the idea that I could do a live simulation project, whatever that is. So we could work together on a project, and I live stream for about an hour certain steps in a simulation project with OpenFOAM. Then I stop at a certain point, I push this to my GitHub account, and you can download the current status of that simulation project. You can try it out yourself, maybe improve it, and next time I can continue from that point on. Maybe I can even use your inputs if you have a good idea how to follow up. So this year I did a couple of polls, what solvers and models you are using OpenFOAM for, and most of you use SnappyHexMesh for meshing, so this is why I thought that I'm going to use SnappyHexMesh. Most of you use SimpleFOAM as solver, so as a first simulation project, SimpleFOAM could be a good solver, and you use the K epsilon model mostly. Maybe we can use the K omega SST, but that's something that's a detail and first and second order. And what I asked you today in the morning is to go into the comment section below this community post and please give me an idea about possible geometry. Now I also talked about so I also mentioned here that it should be an internal flow, because I also posted a poll on that, and then internal flows won by a small margin, but I mean, if you have a really good external flow, that should also be okay. So please give me your comments about possible geometry that we could use in a live stream, and it can be a confidential geometry of yours, or something that you saw that you liked and you thought that would be a cool thing to simulate. Okay, so that's it. So please go to that community post and then post your ideas below there. Okay, so that was it. So let me see some of your comments here. Can you make a video on how to extract forces in sliding mesh? Yeah, sure, possible in the future, but I don't want to start with too complex things in the first live stream. I just want to explore the possibilities. of turbine. Okay, John Wick. Okay, thank you, sir, for your tutorials on YouTube. They were really helpful. Okay, you're welcome. You're welcome, and I'm always really glad to help you. Okay, so then let's jump over to the live stream questions. There are 17 comments, and I sorted them by newest. So I will go to the bottom and start with the first ones, and then I go up, just like last time. No view. So Alberto, I know this question will be too much, but can you do some tutorial about programming crack propagation? Probably this problem is more related to solids for foam. I was wondering how to tackle the code on the random propagation of a crack. I know there is tutorial on fraction of two beams, but it is straight and no random. Yeah, and then ANSYS can do this, and Alberto is looking for OpenFOAM solution in OpenFOAM. So first, it's great that so many of you know already about solids for foam and try to use it, because I personally think that this is a huge opportunity for the OpenFOAM community to expand into structural mechanics. Because with the solids for foam models, you can run solid structural mechanics simulations as well as fluid structure interaction simulations. So it's great. Now regarding crack propagation, I remember that Philip Cardiff, one of the original authors of the solids for foam library, had training session in Portugal. And there he showed us the crack propagation, but as far as I know, it is in experimental stage. I don't know what the current status of that is, so I personally would suggest you to contact Philip with your question, because he is the one who can answer this question. It should work, but I'm not sure how stable it is and how general it is, so for general geometry. So you have to ask Philip about that. Sarah, I'm working on a case combining multiple AMI regions. That's cool, that's a challenging task. And volume of fluid, very good. Later also Lagrangian particles. Okay, so you are doing some high-end things. Could you give some hints what to watch out for in such combinations? For example, tetrahedral cells are not recommended for volume of fluid. Yes, so tetrahedral cells are usually not recommended for CFD in general, so that I can tell you always. Last time we talked about tetrahedral cells, that you can mesh your geometry, but you have to use then polydual mesh, which converts tetrahedra into polyhedra, but unfortunately prisms are not converted. So use snappy hex mesh for that. That's the best for AMI in OpenFOAM and volume of fluid. So I know that what you are describing works for AMI plus volume of fluid. Use the hex dominant measure of snappy hex mesh, and then Lagrangian particles, that's up to you. I have not seen simulations like that, and I guess you have to add them to Interfoam if it's not possible out of the box. So yeah, I personally would advise you to start with one AMI region and rotate your only fluid without any gas in it, then add a second and third into only your fluid without any free surface. And then once you have all your AMIs in your region and they are rotating in the liquid, then you can add your gas phase. And once you have your AMIs with volume of fluid, gas and liquid, then you can go to Lagrangian particles. So this is my opinion on how to do this. So how I would do it. Please discuss, so Yaniv, please discuss about the capabilities and limitations of simulating the plastic injection process using OpenFOAM, whether it's possible to consider the mold and cooling channels in a simulation and cooling and warpage phases, since thus phases are simulated via structural analysis. So I can could talk about this for an hour because I did this as a postdoc before I started Eulerian Solutions. So theoretically, yes, but not out of the box. So what currently in the versions are missing, it's the equation of state, the Tate model that you usually use for injection molding. That's not implemented. You have to implement it or look for an implementation online. Then the non-Newtonian models are there, but they're not there where what you would require usually in a commercial tool for injection molding. So you have to combine possible non-Newtonian fluids, and then you can. And another point is the heat transfer from the melt to the wall. And what no one did up until now is the actual heat transfer throughout the solid wall in the tool. So the best best approach would be to combine this plastic injection molding models with conjugate heat transfer, but that's a very high-end solution. So if you have a boundary condition where you can model the heat transfer, that's, I guess, okay as well, but that's the major disadvantage. And then cooling and warpage, that's something that's something for solids for foam that you have to program yourself. Unfortunately, that's not working out of the box. Okay, Gordon Freeman, can you discuss statics mixers, please? Yeah, so static mixers, I guess that's something out of the box, I'd say, in OpenFOAM. That's not a problem of physics. It's more a problem of geometry and meshing. I did several projects where I simulated static mixers in air, usually to model the airflow. I mean, what could be a problem if you are really interested in the near wall velocity and turbulent behavior on the static mixers? Layer addition in Snappy Hexmesh is a bit problematic, so that could be an issue in your simulations. But if you're not interested in that, for example, I was only interested in the far field, so far away, the influence of the static mixers further away, then just create your STL, set up your Snappy Hexmesh case, mesh it, and then run your simulation. Static mixers should work rather well for as long as you don't need the near wall behavior. Okay, so this is what I can tell you about static mixers. Hello, maybe a case of multi-phase turbulent flows like high velocities. I guess this is a suggestion for my possible future live streams, and if you weren't there at the beginning, then I'm going to talk about my ideas regarding live stream also at the end, so you don't miss it. Okay, so multi-phase turbulent flow, high velocities, this might be an idea for future, but not I want to start slow and with simple geometry and simple problem. Okay, so next comment, hello sir, for the dam break flow, can we apply K omega turbulence model? Sure. There is no tutorial available, yes, for K omega, and in CFD online someone said it is complicated to simulate with K omega. So sure, you can do that. So that is rather simple to do. So if I just go into the tutorials, then multi-phase interfoam, and I guess laminar dam break, and then dam break. So what you would do is change, not transport properties, sorry, turbulence properties. So instead of laminar, maybe there is a RS version of the dam break. Yes, there is. Okay, now. Yes, so instead of K epsilon, you would add K omega, and then the only thing that you have to modify is What am I doing here? Okay, so instead of epsilon, you have to set up an omega file. Just look for any tutorial where the k omega model is used, and just set up the omega file. That's one thing, and then you can just start. What is possible that this model is unstable. For that problem, I don't know, because I rarely use the k omega model. I either use k epsilon or k omega SST. So maybe you might be luckier with the k omega SST model if you are allowed to use that. Then you would do the same thing, just set up an omega file in turbulence properties, add here k omega SST, and one thing you need in FV schemes, here in the bottom you need an additional entry for, I don't remember, but just check a tutorial with k omega SST, and there is an additional entry or setting for those in FV schemes, and that's something that you have to also add. And then run it, and I think with k omega SST it should work, because it's a blending of k epsilon and k omega. Okay, so Franco. So, as always, thanks for these Kanda questions. Could you please point me in the good reference for mesh conversion for Snappy? You briefly mentioned during the last session. I'm a little bit lost about if I should increase the background mesh or level of refinement. Best regards. See you in the session. So I hope Franco is here. Yes, I can see him. So hi, Franco. Do you mean conversion refinement? This was my question here. So I meant this level of regiment in the parameters, number of times Castellan method mesh will define for a workflow to do a correct mesh conversion. Like, do you simulate, analyze the results, then reduce the background mesh, same parameters, and redo? So I think, Franco, what you mean is grid convergence study. And so, yes, so you're right, you have two possibilities to refine your mesh. First, of course, you can increase the refinement level, but Snappy Hex Mesh is hard-coded to refine by a factor of 2. So if you want to do a grid-dependent study, then you can use a coarse mesh, then refine by a factor of 2, 4, 8, 16, and 32. Sometimes it might be a good idea to change it from 1 to 1.5, 2, 2.5, and 3. Then, if you are interested in that, then you can just refine your block mesh, so your initial refinement, and don't do anything in Snappy Hex Mesh. Just leave it, and then you have the refinement of all your cells. Now, this might have the disadvantage that far away from your region of interest, you might not want to refine, just close, and then the refinement in Snappy makes sense. So then you could somehow build up your initial mesh with multiple blocks in block mesh, and then just refine the blocks close to your geometry. But so it depends on what your jumps in refinement should be. If it's 2, 4, 8, 16, 32, then do it in Snappy Hex Mesh. If it's just 1.5, 2 or something like that, then change your block mesh refinement. Okay, so Franco, another question. Talk a little bit about the things you are getting in the OpenFOAM journal, obviously without entering in details. Yeah, so we have a double-blind review process, so no one knows anything. So the reviewers don't know anything about the authors, and the authors don't know about anything about the reviewers. So we already have several submissions under review, which will be through once the reviewers finish and the authors are updating their publications, their manuscripts. So the thing is that we want to concentrate on is reproducibility for the OpenFOAM, reproducibility of results and benefit for the OpenFOAM community. So either one has to be highlighted, and for that we strongly encourage people to add cases or source code to their publication. And I also get the question, why should I submit something in this new journal because there is no high impact factor? Well, yes, but we have to start somewhere. And why should? And I also get the question, why shouldn't I publish it in a high impact factor journal? And there I say, do it both, because in high impact journals, usually they are not really interested in the OpenFOAM specific topics, and then you cannot talk about whole scalar fields and different kinds of C++ specific things there for your implementation, or transport properties or control dict. The reviewers in high impact journals are interested in the physics. So you can submit to the OpenFOAM journal a supplementary paper which talks about the OpenFOAM specific parts, the implementation, or if you have a verification or validation case, there you can publish your OpenFOAM related results, and then the physics is you can then publish in a high impact journal, a high impact factor journal. So we are currently at the beginning. We already had several submissions, but you are welcome to submit something. Please focus on reproducibility of your results and or benefit for the OpenFOAM community. But check out the scope journal.openfoam.com. Okay, so Franco again. So, hi József, have you seen this? I did check out this. Now we can have ParaFOAM easily in Windows. Yes, so thank you. And I took a look at this. So, yes, thank you. Okay, skip ad. So this is a new VSL version with where here in this video they show GIMP, how you can open up GIMP in VSL, but the problem is that currently this is only available for the insider preview, so it does not ship with the current Windows 10 update. So I'll wait until the point where we have where this is inside of the official release of Windows 10. Once it is updated to that release of 21.364, I will immediately do a tutorial about that. But until then, if you are have some experience with Windows and how you can install the preview, the insider preview, then please go ahead. It is a very short tutorial of 3 minutes and 20 seconds, and just try it out with ParaView, Blender, or any kind of Linux applications. It should work. With ParaView, maybe the older versions like 4.3 will work, but I don't know. I didn't have the time to test it myself, but I will check it out. So thank you, Franco, for this input here. So Peter, there are a lot of concepts in OpenFOAM that are certainly difficult to confront as a beginner. That is true, such as the concept of cell sets and cell zones. When someone first encounters these terminologies, what is your recommendation for the best course of action to get to a deep understanding of them? Documentation to follow, practice to do. Well, yes, you can check out the documentation if there is one. So let's see. If we go to Google, OpenFOAM cell set. So there is on the openfoamwiki.net, there is this kind of documentation. It's not a lot, as you can see. And then there is the API guide, so the source code guide. So yeah, I know it's difficult. So there is patch to cell. So some things are difficult to understand. So if you are interested in these two things, these are two things which more or less do the same, but not really. So with cell sets and cell zones, you can select certain cells. You can do the same for faces or the nodes, for so points. So it's just a selection of certain cells, and I think it's historical that you have two different types, because they really both kind of a selection. But with cell zones you can do more, and most models which require cell zones or cell sets do use the cell zones. So for example, if you are doing AMI and you rotate your cells, then you select a certain cell zone that you call, for example, a rotating zone, and this selection of the cells is called cell zones. For the phase zones on the surface of the AMI is also a selection of faces, and then with this selection then you convert the faces to AMI, and then they can communicate between each other. So this is and with cell set is a more limited version of a cell zone, kind of like that. But how to do this? If you're lucky, there is documentation. If you're not, then Google it, go into the source code. Some things are difficult to understand. So I know we are working on the documentation, but it's in our free time, so it takes time. Okay, so Alberto. Hello, can you tell me how to start with a problem in air filters? I want to see how the dust is removed from the air while it passes through the filter. The geometry is simple, just a cylinder. Thanks in advance for your help. So I'm not an expert in air filter simulation, but it's the kind of question how you can model dust and whether it's something chemical or to be with electrostatic force. So it's difficult to answer this question without knowing the possibilities of what kind of input you have and how you want to model the dust and how you want to model the filters. Most probably you would use porous media for filters, but then how you would model the removal of the dust, that I don't know. Maybe someone knows more in the comment section, but sorry, but I'm not an expert on this. Hello sir, can you discuss PDF foam? So I'm guessing this has nothing to do with PDF files. So I think PDF foam is not part of OpenFOAM. Yeah, so PDF foam is not in the official release. Then let's take a look. OpenFOAM PDF foam. Okay, yeah, so PDF foam. Transported library for React. Okay, this is a reactive flow model. And as you can see, it is very old. Okay, so it's versions 1.7 and 2.1. So yeah, what discuss? I mean, somebody would have to port it to recent release because this is very old. I mean, I started with 1.6 in 2009, so this yeah, it was started 10 years ago as you can see, and then updated up until 3 years ago, but it stuck in with version 1.7 and 2.1. So yeah, so you would need 1.7 and 2.1, and back then things weren't as good as nowadays regarding meshing and just solver stability. So you can give it a try, but you need these older versions, and it's also a pain. It's nowadays a pain to go back to those older versions and even install them. So most probably you'll have to compile them from source. So it's difficult. Or somebody would have to port this to newer versions. But I can imagine that this would be some effort, because porting something from and there are quite some files. So yeah, so I don't know this solver, but you'd have to either install 2.1.x or port it to a newer version. So yeah, this is what I can tell you about this. Okay, then let me just go through your comments here. Can you make a video? Okay, so we already had that. John Wick, we already had that. Mixing vessel for the upcoming simulation project. Yes, but I don't want to start out with a very complex geometry. I mean, static mixers, that could be something. yeah, if you have a simple static mixer geometry, we could tackle that in the first live stream. Solidification and melting ins, yeah, that is a very high-end problem, so possibly in the future, but not for the first live stream, sorry. Hi everyone, make video on 6 degrees of freedom in some specific problems. This has been on my list, just like overset, so possibly in the future. Hi Joseph, please talk about non-Newtonian tutorials. So I'm not sure whether there is a non-Newtonian tutorial. There may be in the .org version. So if I go to 8, OpenFOAM tutorial 8, and what would be the best way to do this, to find it easily? Grep and then cross maybe. Okay, so there you go. So PimpleFoam. So there is a specific solver, non-Newtonian icofluid, so you could use that. But PimpleFoam can also do that. So laminar, I'm not sure why it's in laminar, offset, constant. Oh yes, and then in the in the .org version, it's not turbulence property, but momentum transport. Yeah, so there is the cross power law implemented, and then you have the viscosity constant. So there are some tutorials on that. So if you go for generalized Newtonian and you use the grep command in the tutorials, then you may come to that and then take a look at the entries. So these are non-Newtonian tutorials. K omega is a little bit unstable, is better. Okay, so Nicola just confirmed what I mentioned, and Nicola, you're my man. Exactly, so it is wall dist that you require for in FV schemes for K omega SST. Do you have any experience in using transition SST? Nope. Unfortunately not. I'm not a very big turbulence properties guy. I just utilize it. Thanks. Hi József, if you want to study PhD, would you work on ANSYS Fluent or work with OpenFOAM? With OpenFOAM, without a question. Which one is better for finding a job? That really depends where you want to work. I guess if you are looking for a specific job at a certain company where they utilize ANSYS Fluent, then ANSYS Fluent is the way to go. But OpenFOAM knowledge is also very interesting. So I personally would always go for OpenFOAM. If you know that in a certain industry they use only Fluent, then go for Fluent. Hi, can you please explain about adding source term to Navier-Stokes equations in PimpleFoam? So far I have come to know that FV options and help in adding source terms. Exactly, FV options, you can add source terms to temperature, to velocity. Yes, so this is it. If you want to do it in the source code, then you have to program it yourselves. On wiki.openfoam.com/tutorials there are several tutorials on how to program, but FV options is a possibility how to do that. If you look, I'm not sure whether I can quickly find here a tutorial with something with FV options. Yeah, so if you look for FV options, there are a couple of files, so you can just go through these. What is the possibility? For FV options, if you want to use in certain cells the source term for heating or temperature or velocity, there you have to use cell zones, and then in that selection of cell zones, you can add certain heat, for example. So I'm certain that in this file, for example, we will have something for heat. So if I just open it up, yeah, so here Joule heating, So here it is disabled, so that's not a very good example. So let me just see where can we find something more interesting. Okay, so what's this in Interfoam? That could also be something interesting. Okay, so this is now porosity. That's also not something I'm not sure where I can find now a quick way. So maybe here in the heat exchanger tutorial, last tutorial that I'm going to open here. Yes, so constant heat transfer. So for example, this is something. Yeah, so just please go through these tutorials in OpenFOAM, and then some of them will add source terms with FE options. But as you could see, you can utilize it also for other things. How we can avoid negative pressure or temperature in raw pimple. By having a good quality mesh. This is if you have negative pressure or temperature, then your mesh quality isn't adequate for that problem. Or you can reduce the time step size or the under relaxation. So this is something, and add additional internal loops, so N correctors and outer correctors, non-orthogonal correctors. Try those. Those can help also. Okay, so can you do backward facing step problem using OpenFOAM? I mean, so you mean before the live stream? This could be a possibility, yes. So please comment that below the community post. Backward facing, are you there? Some modern CFD books like that OpenFOAM actually uses? Yes, so I did a short video on that, so check out this video of mine. Where is it? Videos, and my latest video here about the technology primer. This is an OpenFOAM related book, and it is free to download as a PDF now. Can you suggest? Yes, so he's recommend. Yeah, thank you, Franco, for your comment. Are there any tools to get good STLs from step geometry? I'm looking for some Python, C++. Okay. I'm not sure. I use FreeCAD. That worked for me. But yeah, so I'm not sure. If anybody knows something, then please answer such in 4K. Tiziano, could you discuss on Eulerian simulations with mass transfer and reaction between phases? So yeah, I know that people use it. I personally don't have a lot of experience with Eulerian simulations, but as far as I know, the basic models work well. Regarding mass transfer and reactions there, I'm not sure. So sorry about that. Any suggestions for the population balance equation solution? So population balance in Lagrangian simulations, I don't know. Any suggestions? So I guess you want how to set it up. This is what you ask. So there are Lagrangian solvers and Lagrangian tutorials, so you can go through these tutorials. And for example, let me just open up a quick. Okay, then not like that. ICO uncoupled. That was the problem. Foam, and then Hopper. And then kinematic cloud properties. There you can set up. So in this file you can set up your distribution. So I hope this helps. Which OpenFOAM solver would you recommend to simulate mass transfer between? That's a good question. I don't know. I would have to check this out myself. So again, mass transfer gas dispersed phase. So I'm guessing this is the Euler. So there are solvers, multiphase Euler foam here, interface change foam. So I would look into these solvers, reacting multiphase Euler foam, two-phase Euler foam. So these are possibly the solvers that you are looking for. And how to check them out? So for example, two-phase Euler foam here. In the C file you have a short description of the solvers. Maybe that helps. Okay, so any suggestion population? Okay, Lookid, about the OpenFOAM journal, how many submissions did you have so far roughly? How many submissions? I mean, we did have a couple of dummy submissions just to test the system. So there we had around 8, but in addition to that, I would say 10 to 15 up until now without the dummy submissions. Okay, how many do you expect for 2021 and what is the deadline for submitting? There is no deadline. It's an open issue, so once something is accepted, it will be immediately uploaded. It's purely electronic, so there is no book that is going to be printed, so there are no deadlines. You can publish whenever you want. We just end the issue by the end of the year, and then if your submission is not accepted this year but only next year, then it is going to come into next year's issue, not this year's issue. But there is no deadline. And how many do we expect? I hope a lot. So I know about several submissions being prepared. I personally also want to submit at least one paper. Philip Cardiff is also preparing a paper where I am a co-author, so there are 2 from my side for this year, so there are several. Hey József, I am a complete beginner with OpenFOAM. Where can I find good tutorials for OpenFOAM? wiki.openfoam.com/tutorials. Okay, if you don't know this, there you can find a lot of tutorials. So this is it. Here you can find a lot of tutorials. Okay. How do you recommend starting with OpenFOAM? This is exactly, so my YouTube channel or this page is what I would suggest. Could you please talk about industrial geometry repair for internal flow, please? Trouble meshing. So there is the online international meeting for users of OpenFOAM, and 2 students from the university in Minho from Portugal submitted a video on exactly that. So once the event is live on my channel, then make sure to check out the videos, because there is a 30-minute video how to do that. Okay, so Franco has an answer to such in 4K, so thank you, Franco. Good tool to create. Salom, yes, Salom, thank you. Thank you very much, Professor. Oh, thank you for the promotion, but I'm just a doctor, not a professor. Thanks. Hi, do you know any experience with CCM to foam or foam to CCM, as both of them require manual compilation? I have no experience with those converters, so sorry. Is it necessary to keep an eye on Y+ value even though we aren't interested in flow near the turbulence layers? So yes, but if you cannot allow yourself that, then, and if you're not interested, then I know that a lot of people just say that's good enough. So it really depends. So if I'm answering this from an academic point of view, then yes, please keep an eye on Y+. As an industrial guy, I would say to make sure that it's not 5,000. Your Y+ is not 5,000 or 20,000, but is in that region of which is reasonable. If you have something with 100 or 200 in certain regions where you're not interested, then I'd say it's fine. And if it is too low, then you don't need the wall functions. Is MPPIC good for simulating bubble columns? I need interaction between bubbles. I don't know. I didn't have the chance to take a look at that solver, but I know that there is this solver. I never know where it is. There it is in DPM form. So transient solvers for couple transport of single kinematic parcels affecting the volume of fluid of particles on the continuous phase. Multiphase is used to represent oscillations without. Yeah, so bubble columns, I don't know, so I cannot answer, just try it out. I know that people already simulated bubble columns with OpenFOAM, but I think it was with Interfoam, and then they added their own code for mass transfer, but I'm not sure. Please check out the tutorials. Have you had experience with 3D overset simulations? I wanted to do that now for these 2 or 3 years. Seems like decomposing the grids are quite challenging or tricky. What would be a recommended approach for decomposition? I don't know about this problem because I only tested the tutorials, and so currently I am working on a tutorial with Michael Aletto on a 2D overset tutorial, but I hope that I can bring it out soon because I'm also very interested in the overset simulations. That is something that I will definitely keep my eye on, and if I find some problems, then I will add this to the tutorial. Any suggestions on how to check if there is backflow at a patch outlet and quantify how much backflow is occurring? So I would just open the results up in ParaView and just load the outlet and then add glyphs, so vectors, and then you can see whether the vectors are pointing outwards or inwards. So this is how I would do it, and quantify it. So the area, I'm not sure whether you're interested in the area or the volume flux. So how would you quantify this? So this is a rough idea, but I would possibly output the overall volume flux. I mean, if it is an internal flow that you know what should go out of your geometry, so what's the mass flux that your geometry has, but which leaves the geometry, and then you calculate the actual value on the outlet, and then you see the difference. But so to see whether there is a backflow, that is very simple with glyphs and vectors. To quantify, that's something that I would have to think about myself. So thank you. Okay, so yes, CCM to foam works for me. I did all WMake, not sure any other method, takes very long though. Okay, so if you're interested, just exchange your email address and then you can discuss this amongst yourself. Thank you for your answer, it helps a lot. So I'm glad that I helped. Which solver is bad for battery thermal simulation? Thermals, thank you for this question, because this is something important to me, because I see that people are using OpenFOAM for fluid dynamic simulations. Now some people are starting to use it for structural simulations, but then I see that people use COMSOL for thermal simulations, and this really bothers me because you can do thermal simulations in OpenFOAM really easily. So the simplest way to do it is with the basic solver Laplacian flow, because all this does is solve the diffusion equation, so the heat diffusion in a solid. So with Laplacian foam, you have everything set up for a thermal simulation, and you can use, and it is so fast because it's not a nonlinear equation. Alternatively, if you have different regions, then you can use CHT multi-region foam and just don't utilize any fluid regions. So if your diffusivity is the same in your entire geometry, then Laplacian foam is to go for. If you have different heat capacities, thermal conductivities, then CHD multi-region foam is the way to go. Just leave out any fluid regions. So where was I? Battery thermal simulation. Yes, so I answered that. What do you think about decomposition for Snappy Hex Mesh? Good idea. So I guess the question is whether to run it in parallel. Yes, so I use hierarchical, that works well, and I run it in parallel, and I use a reconstruct par mesh to bring them together. I just finished the project with 40 million cells. There I had to use decompose par, and it took me 30 minutes to generate 40 million cells, so on 16 cores. So it is great, it works well. So I like decomposition for Snappy Hex Mesh, for big meshes. Which meshing utility you use most, which perspective of commercial geometry, and which you recommend? Open source or commercial mesher for OpenFOAM solvers. So I use Snappy Hex Mesh or CF Mesh, or extrude mesh is also something that I use extensively if the geometry can be set up that I can extrude a 3D mesh into the geometry, or if it is a 2D geometry, then I also use extrude mesh. Now, commercial, I know that, for example, layer addition is problematic in OpenFOAM, and in some commercial codes it's much better. If you are really interested in the near wall behavior, then commercial mesher is maybe better, but I know that for CF mesh the layer addition is a bit better. So before I'd go for a commercial mesher, I test Snappy Hex Mesh and CF mesh, whether they can create a decent layers on your walls, and if they fail, then I would go to a commercial mesher. Thank you. When we perform external aerodynamic, what is the best approach to Y+? So I'm not sure whether the calculation of Y+ or how to set up Y+. So you can calculate Y+ with the post-process command. So earlier it was called it was Y+. So it's not even a command. So let me see whether I can reproduce. Yeah, so Y+ was what it was earlier, and now you can use the post-process function option to and the function Y+. So just run your. If you want to, if you have your simulation results, just run simpleFOAM dash postprocess dash func that Y+, and then this will calculate your Y+ values. If you know that already, then the best way would be to change the layers and the layer thickness in Snappy Hex Mesh. Then which meshing utility you use most for commercial? Okay, so I already answered that. Okay. Is possible to plot a line over time in ParaView? No, that's not possible, unfortunately, but there are function objects for that, so check out the function objects. Thank you for your answer on overset. We look forward to your videos. Question on ParaView: is it possible to make use of multiple codes? Possibly, it is possible to use multiple cores, but I'm not a ParaView pro, so I would go to the ParaView homepage and ask this in the forum. Could you do a small explanation of using extrude mesh from which one? Well, this is Franco. This is a longer topic, so I usually draw the mesh in Blender and then export it as an object file and then just extrude it with I don't know, with the cell. With the mean cell edge length. So this is what I usually do. I do have a tutorial on that on Patreon. So if you want to support me on Patreon, then feel free to check out please support me there, and then you can check out my simulation project with the 2D simulation project where I show you that. But this may also be something for a live stream in future. Okay, before I answer the last questions here, so if you have not been at the beginning here, I would like to bring this, so repeat this discussion with you. So I have posted today in the morning post here. So I want to ask you about what your opinions are on the future live streams where we work together on a simulation project. So I work on it live for about an hour, then I stop, I upload it to GitHub, and then you can download it and work on it on your own for a week or two, and then if you have some inputs, then next time I continue from that point, possibly with your inputs. And for the first project I would like to start slow and use Snappy Hex Mesh, a simple foam simulation with K epsilon, possibly K omega SST, first, possibly second order. And I asked you whether you are interested in internal or external flows, and the poll gave an internal flow. But if you have a very good geometry for external flows, then just please comment below this community post with your geometry, possibly a link to your geometry or your idea. It can be a confidential geometry of yours, but it should be really simple. I don't want to start with a very complex problem here, because I just want to test the possibilities in a live stream, what is possible and what is not possible. So if you have an idea for a geometry, internal or possibly also external, then just please comment and then just give me a link to the step file or STL file, whatever you have, or your idea, and I will check it out, and we will then discuss this in the comment or via email. Okay, so the next live stream is possibly going to be such a project where I work on this. So first I will work on the geometry itself. Maybe I have to heal it. Then we go to Snappy Hex Mesh, take a look at the refinement, and then possibly I stop with Snappy Hex Mesh and then I upload it to GitHub. You can try out Snappy Hex Mesh, and then maybe you find some better settings, and then from that point I will continue on in the second live stream with the case setup possibly, and so on and so on. So maybe 2 or 3 live streams for one first simple project is what I aim for. So please comment regarding your ideas, and possibly in future live streams I can also go back in the community Christmas competition problems. So I would love to simulate the flow around, not around the monkey head, but at least around the sphere, and then calculate the drag coefficient. That would be an awesome simulation project, or even what you mentioned, the backward facing step with a non-reactive flow, but possibly a reacting flow. So these are ideas. Please comment in the comment section below that community post regarding geometry, and then I will announce it. Okay, then a couple of last questions, and then soon I will then stop with the live streams. So I stopped here. Can you couple electrochemical model with thermal model for battery simulation? If you program it yourself, then yes, not out of the box. I'd like to calculate heat transfer coefficient, how to choose T-ref, because the function of post-process wall heat can't work. I don't know. How to choose T reference? That's the far T reference is usually the far field temperature. I don't know. I'd have to see the case and also the error message for wall heat transfer coefficient for post processing. So I don't know. So the T-ref is the far field temperature behind the wall. Thank you for your answer. Is that utility working with latest version? So I'm not sure. Okay, so this is a question to Lava 12005. Perfect, thanks, so Franco. Okay, cool. I'm using version 1912 and it works fine. I will assume it should be working fine. Thank you. How challenging can be geometry be? Porous media maybe. So how the geometry, porous media is good. So if it's just a cylinder, instead that's good. So porous media could be possibly a good idea. Please comment a link to a typical geometry below that community post. And then have you any experience applying continuous species transport method by Marshall and Harun to Interfoam? No, unfortunately not. Sorry about that. Okay, so this was the last comment here, so I will now stop with the live stream. So please make sure to check out this community post and then post possible geometry below that. So with that, I would like to end the live stream. So thank you for being here and commenting and watching. And with that, I would like to thank you for watching and listening. And I hope to see you